It's fantastic to see what the European Space Agency is, dealing Europe back to the top table here. We'll be the first in the world to deploy an AI solution to space, and there's a really compelling need for it. About 68% of what they're able to image from the Sentinel-2 satellites currently is cloud, and being able to filter those out at source gives you a 3 times increase in terms of the downlink bandwidth. Plus there's a multitude of new services they can offer, for instance, detecting if there's a ship at sea, if it's upright or if it's capsized, whether there's a transponder on board, if the transponder corresponds to the image, and so on. So there's a hell of a lot of opportunities there for analytics that can be deployed to space. It can give you very rapid reaction times. I mean, we saw what happened in Notre Dame. You can imagine if that had been a forest fire somewhere. If it takes you three hours to find out that there's a forest fire, it goes from a situation where somebody could jump out of the back of their car with a fire extinguisher and put the fire out to something where you need a fleet of Canadairs and hundreds of firemen to put it out. So I think that's really groundbreaking work that's happening here in Europe. Equally, what Movidius are doing in terms of warehouse management systems, they're able to get to the point where you can track everything in a warehouse. You can have a big impact on logistics and so on, completely based on computer vision and AI at the edge. And in fact, the same company, Movidius, has done very interesting solution for the health market to be able to diagnose in a, let's say, a GDPR-friendly way, whether somebody has diabetic retinopathy. So I think this is that kind of range of applications is showing how AI is really helping to offer innovative products and services to the market at a very low cost, and it's all enabled by edge inference using whatever platform is out there. And I think it's a very exciting time to be involved in AI, particularly at the edge. Really, the challenge came not so much with being able to train neural networks, but with being able to deploy them into end-user devices that we could use that don't require a big PC. So as soon as you want to scale that down and make it battery-powered, you kind of have to design new hardware for it, because if you try and deploy what's in a desktop, you end up with something that, you end a battery pack this size. So that's what makes AI interesting from a hardware point of view, is that the real challenge is there, not just to get performance at any cost, but to get performance per watt per dollar, so that you can deploy this on a massive scale. And that requires a multitude of skills, from people who do the actual hardware design to people who do the embedded software, APIs, compilers, and the front-end tools that developers would use. So it's a really multidisciplinary effort, and I think that makes it very exciting. There's a few hundred probably startups worldwide in AI hardware, and it's meant there's been a real war for talent, but also maybe in some ways I think there's an opportunity for academics to deal themselves back in, because when there's a rush to the market, maybe not always the best ideas are coming to market, and I think there'll be a kind of a settling out phase from all that AI activity, and there'll be a second round from the people who survived the first round to go again and develop better products in the second round. So it's by no means over. It's not like you're going to design AI hardware once over. This is going to be a continuing, evolving process. One of the things that Intel wants to do is to make the technology accessible to because you can't predict what's going to happen with AI. I think I explained already that there are as many applications as you can imagine for this technology, and really putting getting the technology at low cost into the hands of the students, getting things like OpenVINO, the SDK, into the hands of students for free. They can just download it and run it on their Raspberry Pi or their Ubuntu laptop or their Windows laptop. It means that they can start to try out things. And if you combine the availability of that hardware and software with things like Fast.ai, which is an online AI training course, and you can basically get to the point where you can train a network to do, let's say, inference or cat-dog detector, and deploy that onto a neural compute stick in less than an hour from basically only knowing a bit of basic coding at the beginning. So I think doing things like sponsoring these student challenges allows us to get the word out there, get people familiar with the technology, and then they can help companies to deploy it.